Hi, welcome to the lesson about Windows. So Windows are maybe the easiest way to understand stateful processing because they are delimited in time, and stateful processing will very often reason in terms of time. But you will see that there are different types of Windows that can make your life, at least in the beginning, much harder. But there is no rocket science. It's quite easy to understand once you get all the details of each type of window. And in simple terms, a window is a space delimited by time that can integrate late data. And the glitch here is that something that I already told you before, even though you emit the result of your window as being a final one, as complete one, due to the GC watermark, well, in fact, you may still get some late data that was quite long, very late, and in that case, you will not be able to integrate it to the results that you have just emitted. So that's why I put the final, like not real final, in fact. It's final from the GC watermark standpoint, but it's not it may not be really final from the input data you are getting, and especially the very late data you are getting from your producers. So there are different window types: the tumbling window, the sliding window, session window, and we can also find global window. I'm referring here to the terms you will find in main data processing frameworks, namely Apache Spark Structured Streaming, Apache Flink, and I think there is also Apache Beam that uses the same nomenclature. And here I will give you a visual example of them. And the first of them is the easiest one, is the tumbling window, when you define just the window duration. So you generally divide your timeline into equal parts. So here we have the windows of 10 minutes. We integrate data according to the event time, like just in this animated demo. The second part is the sliding window. So here we also have the window duration, but you slide the windows so that you can have some overlapping windows. Here we have the sliding duration of 5 minutes, meaning that we will create a new window of 10 minutes every 5 minutes. Let me give you an example. So this is the tumbling window. Remember this picture. We have 3 distinct windows. And now when we apply this sliding window, you can see that we have still 3 windows, but this time they are overlapping because every 5 minutes we create a new window of 10 minutes. And you can see that the 10:07 is included in the first window for 10 to 10:10, and for the second window from 10:05 to 10:15. And there is also another variation of the sliding window when you can lose the data, because here the sliding duration is bigger than the window duration. So here we create windows every 15 seconds for the windows of 10 minutes. So we have the window created at 10:15 until 10:25, and later we have a window for 10:30. So we miss the 5 minutes here, and we miss this particular record. So personally, I don't see any interesting use case for that kind of windows. That maybe it's good to know that you might have this phenomena if by mistake you misconfigure this sliding and window duration. But if you would find one example, well, please ping me because I'm still looking for it. And the third type is the session window. So the session window is a kind of similar case that we saw previously with the arbitrarily stateful processing when we were rebuilding user navigation. So here it's a kind of automated. We define the key of our session, and we define also the gap duration. And the gap duration is a kind of inactivity allow for each session group. So here we have the gap duration of 10 minutes, and the session key is the color of our item. And we have the items for the gray color. We open a new session window. And with the gap duration, we know that the window will close at 10:05. Now we get new data. So we get the data for 10:02. It's before the gap duration, before the end of the window. And now we can also increase the gap, the window the window end period to 10.05. And now whenever we get any new value for this group, or either the GC watermark passes by, when we create a new window. Typically here we get new data because, and the gap duration is bigger than 5 minutes. Well, bigger equal than 5 minutes, and we can create a new window and emit the results for the previous one. And another important part is that is that this session window is key based, so each key has its own session window, meaning that here, even though we get some data for 10.06 for the orange session key, well, we can still keep this session window open as long, of course, as it doesn't reach the watermark, the input watermark. So it's again the same story, and we can even have the same gap duration for this window. And the final one is the global window. So this kind of window is very famous and popular in the frameworks, relying on the windows to implement and to represent the streaming world. And here your whole streaming job is a one single big window. The window duration is indefinite. So we have data for 20th of May. And now when we go to the next day, we still integrate it to the same window. It can grow really huge. That's the reason why, when for whatever reason you need to use this global window, you should always be careful about the state you are accumulating. And I mentioned it already a few times in this lesson. There is the GC watermark that is closely related to the window. So here you can see that we have our current time 10:50 and watermark, which is at 9:50 for the window duration of 10 minutes. Now, when we update the GC watermark, we clearly see that we are saying that we will not get any data prior that period, so we can emit the windows that are in our state. And generally, that's all you should probably know just in the beginning, just to understand the Windows concepts. Again, there is a demo lesson following this one that should give you code examples on how to implement the different windows. So thanks for watching, and see you in the next lesson.